Good morning, good afternoon, good evening. Welcome to episode number 62 of the Unboxing AI webinar series. Uh, every Thursday, as it comes quite fast, actually, I've realized. But yes, every Thursday, 11 a.m. Eastern Time, you will see me talking to one of our friends, collaborators, customers, partners, trying to unbox the proverbial black box of AI and try to get some insights and thoughts going as we build this ecosystem of clinical AI solutions. If you don't know what Carpal is, well, we are your bridge between this relatively complex world of AI applications, multiple body parts, modalities, disease states, etc. So bridging this gap of AI, bringing it right to your clinical workflows to a single user interface, single data channel, single procurement channel, and all that good stuff. So without further ado, today we have with us Dr. Sohail Contractor. Uh, dear friend who I stalked at RSNA a few years ago, and then finally managed to show him a demo of our product. Dr. Contractor is he's the chair of radiology at University of Louisville. Under his leadership, it's grown really a lot, and I'm just trying to pull out his bio so that I don't get any of this wrong. Yes. So he's a radiologist first and foremost at UFL. He's the chair of radiology. Studied in Mumbai at Grant Medical College, very close to where I studied. I studied at Sion, Sahil. I don't know if you know that.
I
Uh,
know, you told me that.
nice. And then he did his medicine residency at Coney Island Hospital, and then did radiology at NYU. Seems and was at Rutgers prior to taking over at Louisville, and one of the earliest users, if I may, of AI, in our like relatively nascent world of AI. But so here, as is customary in these webinars, uh, what do you do as if you were telling a 5-year-old?
Okay, well, first of all, Vidur, thank you, for having me here, and thanks to all the participants who have, spending an hour with us. What I do is I have a lot of fun. That's what I do. So I'm a practicing interventional radiologist, as you can tell from my scrubs. And hopefully my fellows and residents doing cases while I'm here don't mess it up too badly. Um, I have also, over the past 5, 7 years, become, first an AI enthusiast and an early adopter, and now, I think a little more seasoned, person with having some views, I suppose, based on, what I've seen the field grow into. I've also been very lucky here at Louisville to have been able to set up, a center for AI, as we've spoken about, along with some members of my engineering school at the University of Louisville. So, we also engage in research, making IP, uh, building some algorithms, publishing, educating. So, but all in all, like I said, I just have a lot of fun at work. So that's kind of what I do.
Nice. I think that is the ultimate description for a 5-year-old. Like, what do you do? I have fun. Simple.
Exactly. Yeah.
That is I think the most amazing definition I've heard. So here coming to the world of clinical AI, and we were talking about it prior to the session as well. Uh, one, like, what AI do you use today in your practice? And secondly, how did you get to this point, right? Uh, how do you today, one, do you trust it? And if yes, like, what was that journey like of getting to trusting AI?
Yeah. So, yeah, a lot of questions. Basically, I started looking into AI back in New Jersey about 2018, 19, when I think, and all of this came about based on, NVIDIA being formed and making all this noise. And then I think one of the first companies I came across was Wiz.ai. Um, and that seemed very fascinating. And then, of course, other companies have come. So, but when I got here to Louisville, one of the sort of um, uh, chair packages, if you may call it, that I negotiated for was the ability to, to build, AI into our practice, and also to build, some kind of research facility along with it. So, so I was very lucky, when I did start, it was also, peak COVID, which also meant that most administrators really didn't, care too much about all these small details because they thought, well, this is just, it's a new chair. He wants to have some fun, so let's just, give it to him and let him go with it. So we basically, you know, uh, partnered with and I don't know if I, want to name companies on, but we partnered with
You
a
can,
fairly,
like, we have no problem. The
you don't
like,
have any
there's
problem.
no
Okay.
restriction from our side. Yeah, we
Yeah.
love it. In fact,
Well, I mean, I
yeah.
don't know if the company might like it or
Okay.
not because but anyway, so this was AI Doc, that we first partnered with, and their algorithms for brain bleeds and PEs were really what were the fascinating ones, and I mean, the data they had out, the technical data, the model building, the validation, things like that, were all very good, and they were largely untested, right? So we actually deployed them towards the end of 21, early 22. We were literally one of the first, sites in the country, to start using clinical validated, commercially deployed AI. And, we paid a lot less then than what we just renewed for, I can tell you that. But the interesting part was,
On behalf of the AI startup community, I thank you.
yeah. So what was very interesting about that early deployment was while we had some very early adopters and champions, and I think one of them is on the panel, or on the audience, as I see his name, Dr. Joshi, but also a lot of naysayers, right? Because, like, it's very common to expect people not to want to accept new technology. I mean, that's happened across the centuries where people have just basically denied, like, yeah, this is all garbage, this is not for me, I can do a better job. So we had a very interesting, first year of rollout, which was that, when these outputs would come out, we would, obviously, they were like floating icons, so we would see the icons down in the bottom of the pack screen, and that's something else we can talk about later, in terms of how the outputs are, displayed out. But I will not say most, but I would say that there were still some holdouts in terms of who would actually check the output and not. And the one smart thing AI Doc had done at that point, not to give them a plug, because but the one good thing they had done at the time was they also had natural language processing for our reports. So if their study had flagged a pulmonary embolism, and their NLP protocol did not find pulmonary embolism in the report, they would send us, a an email saying, hey, our algorithm flagged a PE, but you guys missed it, right? So
Hmm.
that was very interesting. I had, again, me and my co-conspirator in putting this on would look at these, and he would arbitrate, yes, there was a PE, no, there was no PE, and then we would send out an email to the radiologist who had chosen to ignore it, right? Basically. And then we, at the end of the year, several studies, critical findings that were essentially missed by the radiologist, right? And granted, not all of these were likely clinically significant, but they were findings. So when we went back at the end of the year and said, guys, this is where we are, so that piqued a lot of interest and turned up their antennas, right? That this is like something good, because you're missing a small finding which may be critical. And certainly, if you end up in a court of law with a critical finding missed and an AI algorithm flagging it, and you're still missing it, you probably will not do too well. So,
Hmm.
glad to say that those number of sort of alert emails have really, really, really fallen, down now. I mean, we get maybe one every 3 months. And
Oh,
that
wow.
also, yeah, and that also because, a lot of our practice, is not only internal, but we have some external, sort of vendors that provide some tele services to us. So some of those are there, and then so that was very interesting to note how, and it's not, I mean, not surprising that humans would, would doubt technology, and as they should, right? I mean, because yeah, why not? I mean, why should you just blindly trust technology? So, and then we had other, algorithms that we put on, and maybe I won't name that, but that didn't quite perform to our expectations. So we kind of turned it off, at least for now, until they get better, maybe, or they come back with something different. And I mean, AI Doc has expanded its platform.
What could that company have done differently? So, like, was it purely just a algorithm performance issue, or is
Yeah,
there like
some of
a
it was
training
that.
aspect to it, or like?
Yeah,
And
some of
I'll
it
tell you the
was.
reason I asked, it
Yeah.
is because a lot of people who listen to this, this goes on YouTube later, are people who are wanting to build AI startups and, kind of, so that's the perspective that would be very valuable.
Yeah.
Like, what are mistakes that, people trying to build should avoid.
Yeah, so some of it was definitely that the models might just not have been good enough. Like you had EKG leads being read as pleural lines for pneumothorax, and you had the whole lung being outlined for abnormality, which does not really make sense, right? But I think also at the end of the day, the challenge was in the setting in which things are deployed also. So that's actually a good point, Vidur, because um, when you have these normal abnormal classifiers, like for chest x-rays, let's see, right? If you're going to deploy that normal abnormal classifier in the ICU, for ICU films, everything's abnormal, right? So nobody cares, right? So really where you want to deploy them is where your likelihood of normal is higher. So that you are actually catching the ones that you need to catch. Just like the bone algorithm, from Gleamer, which is why we haven't deployed it, with us yet. Their fracture detection is sensational, but the problem is most of our X-rays, that are done fracture follow-ups. So
Yeah.
everything is going to be abnormal on those. So we chose not to. So I think, for a company person learning, I think making sure that the right environment is where your algorithm gets deployed is very crucial. And maybe we could not figure out how to not deploy it on certain machines or certain outputs, but that's where we were. So it became pretty challenging. And of course, again, the model also was not, I think, could have done better in terms of many different things. And by the way, this company just was voted as like, to the Times 100 and all that. So it's a good company. Obviously, they're doing very well. But and then you also come down to your training sets and your testing sets, right? So if you've got models developed out of your practice demographics, those models might not necessarily perform very well in your practice demographic. So, and this could be a big thing, in mammography in breast, where, you know, women have different breast densities in India and China than they do in America and Europe, right? So, if you
Yeah.
are building a model, you better make sure that where you deploy it is where your population is likely to match, because otherwise your models aren't going to perform well.
No, I think it's a very valid point. Like what you were alluding to was, if I may paraphrase, that
Yeah,
filter out those studies where your AI is not valuable, and don't run it on those studies, and kind of only run let's say in the in the ICU example you said, like if you have a chest X-ray normal versus abnormal classifier, figure out a way where you run the model on the most normal, or the
right.
most pre-test probability of there being nothing,
Correct.
and because we coming from the startups perspective, right? We measure scans per day, right?
Right.
But and so it's a very infatuating thing to say, oh, like I am running all of University of Louisville's X-rays through my AI. Like I'm running 2,000 X-rays a day,
Right.
whereas I am only valuable in 200 of those
Correct.
2,000. So
Exactly.
I'm actually
Exactly.
doing injustice by to myself
Exactly.
only by running on those balance 1,800. So I think that
Right.
is a huge insight. Like, and it's not easy to filter those cases, right? Like because there's some EMR tag or some risk tag, or something that uh,
Yeah, we could not do it. We could not do
yeah.
that. That's why we turned it off, because you're right. It was
Hmm.
kind of, causing alert fatigue, and then, over calling some things and under calling some things. And, um, so, for us, from a even from a sort of ethical medical legal perspective, it became a
Yeah.
problem to, to acknowledge those alerts and and then to say, yeah, there's no pneumothorax because that's an EKG lead, right? I mean, so that becomes a challenge also. Oh.
Interesting. So, how does this, Dr. Contractor, and I'm going a little bit off script, but like, the failure of, say, company B, does that affect the radiologist's perception of company A and then a future company C? Or are people able to tell that, okay, it's not that all AI is same? Like,
Yeah,
different models can have, like, what is the psychology and, like the
yeah,
trust interpretation behind such a
yeah.
situation?
So again, if you deploy of five companies, if three are not good, right, then your likelihood of trust in the other two is also going to go down. But I think,
Hmm.
radiologists intrinsically, as you know, I mean, by the way, for the folks on the thing, to introduce Vidur, his dad was one of the pioneers of radiology in India. So for him to be doing what he's doing is truly remarkable. And, they're a 4-year-old company. And I met him, about 3.5 something years ago. From what he was to what he's grown is like, is truly amazing. So yes, so
See, see
that
how I'm not,
radiology.
see how I'm not stopping you.
Yeah, I can go on for the next 40 minutes. Yeah. Um, so, well, as and I say this because your dad's a radiologist. So
Yeah,
radiologists in general, I can say pretty confidently are really, really smart people, and trust me, nobody knows that better than a guy who manages a group of radiologists. Okay. So, so when you're a chair of a group of 50
and
or
very
60.
good negotiators also.
Yeah, yeah,
To
yeah.
everyone.
Yeah. So you learn very fast how smart these people are because they're just so damn smart, right? And it's like so difficult. Uh, so radiologists are smart people. They understand that there's some things will not work well, and many things will work well, right? And again, we are still in such infancy in this field that we're kind of at the flip phone stage of the smartphone generation, right? We haven't even come to, like, Apple's first smartphone yet. I mean,
Yeah.
we're still, like, very early in this field. So, um, yeah,
So that means that, what you're saying is that generally people are able to tell that it's not that, and maybe today it's more, relevant that out of the five AI solutions, if two are good, three are bad, then two are good and three are bad, right? Like it's not that all five are bad because three are bad.
correct, correct. Yeah, like I
Yeah.
said, so, I mean, again, not to give AI Doc a
Yeah.
plug, but giving it a plug. I mean, most of their models perform very well. We've seen very few false positives and false negatives.
Yeah.
Um, of course, that is harder to measure because, we would literally have to, just do a random, look at all their outputs and then see what we agreed with or not.
Yeah.
Um, yeah, but I mean, we've now just got, a breast, algorithm in. We haven't started it yet, but we are hoping that it's going to help us with some of our breast reads. Yeah.
Nice. So Sunil, we just have a question that's come in from Dr. Clement Grazi.
Yeah.
Uh, and, they ask, as an IR physician myself, some of my colleagues think that due to the hands-on nature of interventional radiology, that AI will have less penetration versus pure diagnostic imaging.
Yeah.
Yet, in my view, many aspects of IR lend themselves to AI. What's your
Yeah.
take on that? Very
Yeah, so I
interesting.
mean, clearly we do a lot of, I mean, we are a procedural based field. So, unless you have an autonomous robots doing things that we do, which is going to take a long time, but there's several areas that it will impact, and it may not impact, on the visual or the procedural aspects, but certainly on the language model aspects of it. So, there are language models that will basically prepare a whole IR report for you as you're doing your procedure, right? I mean, so you don't have to go back and dictate that. It's ambient dictation. You're going to just talk about what you're doing, and then you come up with a nicely made procedural report. Um, Before you're even done with the case, right? So that's a pretty useful thing. And then you have lots of follow-up opportunities, right? I mean, if you're treating liver cancer, you can have automated liver segmentation, to help
Yeah.
map your Y90 doses, to help follow up your patients. So I think there's a lot of things that will, I mean, and certainly if you use AI Doc, they have their pulmonary embolism care coordination platform. So that is clearly a big advantage to have, or your brain bleeds, or your stroke. So yeah, it probably will not take away our ability, or our usefulness in the procedure part, but there's lots of other things outside of it that AI or assisted medicine will help us with.
In fact, Sahil, my view is that, as an IR doc, you may still be doing, I don't know, 10, 15, patients a day.
Yeah,
As a
on a
radiologist with
slow day.
AI, yeah, on a slow day, as a radiologist using AI, you might just start doing like it happens in the world of blood testing and pathology, right? You might start doing 5,000 patients a day. So, right, and which is why some of the world's most profitable companies are pathology companies. Might the I think the decision might end up being, between 2,000 patients a day versus 20, 40,
Yeah,
whatever X number per day. But very, very interesting. I think this is the first time on the webinar that this IR, like disruption of IR, has been talked about. So amazing. Uh, I think one another question has come in from Shruti from our team. Shruti asks, from your experience, how do radiology residents perceive AI today?
yeah. So I think
Yeah.
the younger generation is more ready to adopt to the cooler things, right? So all of our residents, I mean, in fact, the ones that have graduated now, they will frequently, if not call, but certainly when we meet up with them, they're like, wow, this was, it was really good that we had the exposure we had. And because, I mean, in our place, as is happening in many places across the country now, we have a formal AI curriculum. So one of our research
Oh,
faculty
okay. Wow.
teaches AI, to our residents. I mean, and they talk about model building, and what the different parameters are, and what is a CNN, what is machine learning, things like that. So our residents are very, appreciative. We've also now gotten into, of course, chat GPT based LLMs, modeling things, and preparing reports and looking at diagnoses and preparing case scenarios. So yeah, I mean, the younger guys are going to get it first, right? I mean, this the older guys like me that had to catch up. So
Yeah, right. So Sahil, we were talking earlier about CARES, which is
yeah.
the Center for AI and Radiology Sciences. Uh, why start a research unit focused on AI, and that to radiology AI, like, and what have you seen through it that maybe
Yeah.
our viewers would find interesting?
So I mean, I was inspired by Stanford Center, Amy. Again, I
Nice.
hate to take people's names here, but that's kind of back in 2018, 19. I had been to one of their meetings, and it was like, wow, this is good. It was like a small group. It's much like what we are, and they're basically just getting together the people in the institution that have an interest in the field, right? So,
Yeah.
so again, part of my chair package was a endowment, and I had to use money somewhere, and it was like, all right, this is probably the coolest, because again, not to put the University of Louisville down, but the field of AI was a great leveler, right? And it is still a great leveler because everybody's starting out from ground zero.
Yeah.
So if
Yeah.
you can, build and become, good at it, you would be just as good as anybody else, and without, having to try and catch up to some of the more established names out there. Although again, UFL, has its names in a lot of different things. So I think that was the motivator to get a good group of individuals interested in across the institution. So we are lucky. We've got a computer science school, we've got a engineering school, we've got a bioengineering school, and people from all of these had one or two people here like me, like, oh yeah, AI seems to be fun. Let's learn more about it, right? And then I was also lucky that we had a PhD guy in my division who also had an interest. So he's taken on like a big role in at least the educating part, in my department and across the institution. So over the past 4 years or so, we've done a number of things. We've published a bunch of literature, either new or review literature. We've built a couple of models. We've submitted for IP for a couple of those,
Wow.
and we've hosted our regional sort of AI meeting. And I know you've been to one of those. And again, it's not a groundbreaking world stage, but it just helps to raise the awareness at our level is what I try and do with the medical students, with our local community. So yeah, so that is sort of the premise of wanting to have a research, come educational center started in the department. And that's been good. It's been noticed by
Yeah.
the institution. Yeah, so we've now started to put together, a plan to make a university-wide center, which obviously would be more than just radiology. But that's been happening now. Hopefully, in the next 2 years or so, we will have that also.
Nice. No, that's I'm sure, many uh chairs of radiology would get inspired, and there is like hopefully this whole movement towards setting up of research units dedicatedly for AI research. As you said, it's democratized, right? It doesn't cost much to set them up, to be honest. It's just people and a little
Yeah.
bit of compute infrastructure. You don't need wet labs, you don't need expensive like 14 Tesla MRI scanners or something. So that's I think that's the democratization of uh, caused by tech. Um,
Yeah, I had to buy, obviously computing, computers, 100 grand or so, but that's okay. That's not, that challenging. Yeah.
yeah. So there's a couple of more questions. We're hitting almost hitting time. So this one's from Amir Khusro Kazemi.
Uh-huh.
I think Amir is from University of Louisville. I'm not wrong.
Yeah,
Uh,
yeah,
you
yeah.
know, so they ask, what types of AI products do you consider promising for a radiologist and are worth paying for? Most importantly,
Yeah. So I would say couple.
we got our 5 second. What we want.
Yeah. Well, uh, so
No, but yes, but use cases. So, what is your dream use case? I will, kind of re-ask that question if I may.
yeah.
If I was starting, or if somebody was starting a radiology AI startup today, and they came to you and asked, "What should we build?" What would be your answer?
So I think, like I said, we are in very infancy. I mean, people have basically taken the list of critical findings from the ACR website and built algorithms around that, right? And that's okay because it helps radiologists not miss things, or helps them read, things from a better perspective. But I think we really haven't tackled, you know, human problems, right? I mean, so like, can you build an algorithm that, if you do a chest X-ray, that can predict your risk of cardiac disease and cancer and hip fracture, right? And depression, because all of these things are the things that plague, us the most, right? I mean,
Yeah.
we either, as we get older, we either lose our memory, get depressed, right? Or we fall down and we break our hips, or we get a cancer, or we die of heart disease, right? I mean, those are like four things that really afflict human beings. So that would be the ultimate like sort of thing, right? The big questions are what is going to be needed in terms of model build, what parameters, what data do we need to predict those bad outcomes. So uh, these little one-off things are okay, and they help radiologists, and they sound cool, and they get me invited to a webinar. But at the end of the day, know the real questions are the real questions. So I think the real
Yeah.
questions are going to be in genomics. Like, you
Yeah.
take a cell, like what is your long-term risk of getting this thing, right? I mean,
Yeah.
what is your risk of getting a cancer?
Yeah.
So that those questions we really haven't answered as yet. And then the other thing, I mean, I'll throw this out there because I was reading about this. Does the field of radiology even need to exist, right? Do you even need to make an image? Because as a radiologist, and that when a CAT scan acquires an image, it doesn't acquire an image. It acquires binary data, right?
Yeah.
It requires yes, no, grayscale data that gets converted to an image, and then you're running the image through, through a vision model that tells you whether it's there or not, and that vision model is basically looking at that grayscale data. It's not looking at the image itself. It's looking at, yes or no, right? So do you even need to have an image made? I mean, like, why can't you run the raw numbers that a CAT scan or an MRI gets through your algorithms and then tell you, yes, there's going to be a bleed, in this parietal lobe or in this occipital lobe, and then maybe give you a sample image of that just for the fun of it. But at the end of the day, you probably don't need radiology in the way that it exists today, because a lot of it will just be based on what that, the imaging background data is telling you. So the image is a representation of those numbers, so you don't need the image to make the model. And I think
Yeah.
that's the more fascinating thing that I'm thinking of. Like, is this field going to be decimated because of that, or because we're
Yeah.
going to build vision models?
So I think, Sohail, I can keep talking to you about that for hours, because there is also this whole thesis. One is, of course, you go from raw data to diagnosis. The other is, what if neurologists started using reading brain MR, and what if
Yeah,
pulmonologists started
yeah.
reading, chest CTs and chest X-rays, etc. So, but we try very hard to stay on time, so I will have to kind of
Okay.
cut right now. But
No, no.
and we will let you also go back to doing some real work. But thank you so much for doing this. And thank you so much to everybody who joined. Shashank from my team had asked a question, but I will ping you on that offline and
Sure.
get him his answer. But
Okay.
thank you, Sohail, for joining. And thank you to everyone for joining. I think this has been great. Thank you so much.
Thanks. The pleasure was mine. And
No, please.
carpal, guys, carpal, use that.
Thank you so much, Sohail.
Take
Thank
care.
you.
Thank you.
Bye.
Take care.
Bye.
Bye.